Hello students, in today's session we shall discuss the solid state. You know that matter is classified into three categories depending on its physical state. They are solids, liquids and gases. As our lesson is solid state, so we shall discuss some general characteristics of the solids. We know that in solids the constituent particles are arranged very closely to each other, leaving no space between any two particles. So due to this close packing arrangement of the particles, solids attain a definite shape and they possess a definite volume. But in the liquids and the gases, the molecules are not arranged so closely like solids. So that's why in liquids and the gases, the molecules move randomly in all the directions and they do not possess a particular shape and the volume, and their volume of the liquids are having the volume, but a gaseous volume and the shape depending on the type of the vessel they present. But in the case of the solids have the definite shape and volume due to the close packing arrangement of the particles. Now let us see some general characteristics of the solids. As I said just now, solids have definite volume irrespective of the size or shape of the container in which they are placed. Solids are rigid and have definite shapes. The rigid nature of the solids is because of the close packing arrangement of the particles. Many solids have crystalline appearance and have definite pattern of angles and planes. This we shall discuss in the crystalline solids. Solids are almost incompressible. Solids are incompressible because in solids the particles are so closely arranged so that you cannot reduce the volume of the solids by applying the pressure. Solids have much higher density than that of the liquids or gases because more number of the particles are placed in the smallest area in the solids. Solids diffuse very slowly as compared to the liquids or gases. This is because in solids there are strong attractive forces among the particles, hence they cannot move out of their position. Most solids become liquid when heated. Some undergo sublimation because when you heat a particular solid, the attractions between the particles in solid becomes weak and the solids become liquid, and in case of the iodine camphor, the type of the solids, they directly undergo sublimation. Now let us see the type of solids. So this is the classification of the solids. Solids are classified into two categories, namely crystalline solids and amorphous solids, based on the nature of the order of the arrangement of the particles, means whether the particles are arranged in a regular pattern or irregular pattern. So based on the type of the arrangement of the particles, the solids have been classified into these categories. So let us see the first one, crystalline solids. In case of crystalline solids, the particles are arranged in the regular pattern. For example, if you take a crystal having the AB particles, so the particles may be arranged like this. So in crystalline solids, if you observe clearly, the pattern of arrangement of the particles is regular. Means if A comes first, next B means again A, again B, A, B. The same order it maintains till the end of the crystal. Hence this order is called as the long range order. You can see this side also it will have the same pattern, A, B, A, B, and here B, A, B, A means same pattern will be there, A, B, A, B pattern. And these crystalline solids are called as the true solids. These are having the sharp melting point values because they are having the same type of the attraction force. See here, A, B is there, again A, B is there, again A, B is there, A, B is there. So attraction forces are always same. So when you heat the crystalline solid, all the attractive forces are equal, hence they will be broken immediately with the same energy, and at a single temperature these solids start melting. Hence crystalline solids are said to be having sharp melting point values. and these are anisotropic in nature. This means you can see along this direction the arrangement of the particles is AB, AB, AB. But if you see along this direction, the arrangement of the particles is somewhat different. Along this direction only A particles are there, or else only B particles are there. So when solids are having this type of arrangement, they show different properties when you change direction. So if you try to see the refractive index from this direction, it will give one type of the value, and along this direction it will give another type of the value, and along this direction it gives another type of the value. So certain physical properties are not same for crystalline solids along all the directions due to the difference in the arrangement of the particles on different directions. So such type of the properties are called the anisotropic in nature. Now let us see the properties. So these are crystalline solid properties as just I discussed. The internal arrangement of the particles is so regular, so they possess definite and regular geometry, hence they have long range order as they are coming regularly. There is a regularity in the external form. So when crystals are formed, crystalline solids give a regular cut with a sharp edge knife. So if you cut the crystalline solids this direction, all these surfaces can be cut at a single application, or else you can cut the solid along this direction also with a single application with the knife. So they give the sharp edged crystals because they are having the same type of the pattern of the arrangement of the particles. So crystalline solids are hard, rigid, and their shape is not distorted by mild distorting forces. So when you apply the forces, the shape of the crystalline solids cannot be changed. Crystalline solids are having the sharp melting point, which we have discussed due to the regular arrangement of the particles. Crystalline solids are anisotropic. Just now we have discussed that particular point also. Let us see amorphous solids. So in the case of the amorphous solids, the arrangement of the particles is not like in the case of the crystalline solids. So in case of the amorphous solids, the arrangement of the particles may not be regular. See here you can observe A particle is there, again B is there, again after 3 particles are arranged, again B particle, again A particle. So we are not sure that what type of the arrangement of the particles is present. It may be any pattern. So we call it as a irregular pattern of the arrangement of the particles. So if you cut this particular type of the particles with a sharp edged knife, they don't give the smooth surfaces because the particles, their arrangement and the attraction forces are different along different directions. Hence when you cut, they give the rough surfaces. At the same time, when you apply the heating, when you try to melt this particular type of the crystals, as they do not have the same environment, so one particular area starts melting at one particular temperature, another particular area may start melting at another particular temperature. See here, this particular B particle is surrounded by 2 B particles and 2 A particles. But if you see this particular B particle, it is surrounded by the only A particles are there. So the environment around this B particle is different from this B particle. So here the attraction forces may be strong or weak, or here also attraction force may be strong or weak. When you apply a particular temperature, if the attraction forces around this B particle are weaker than this particular B particle, then this area first starts melting, this area will not start melting. And when you raise the temperature and this area may start melting, this area may not start melting again. So it differs from area to area. So that is the reason why we say these amorphous solids are having the range of melting point values. Range of melting point. For example, if you take the plastic material, when you try to heat a plastic pipe, initially directly it will not become the liquid. When you try to heat a plastic pipe by giving this some 90 degrees centigrade of the temperature, the moment when 90 degrees centigrade of temperature is reached, imagine the plastic pipe do not convert directly to the liquid, initially it becomes the soft material. And when you go from the 90 to 100 degrees centigrade, that particular soft material may become the viscous liquid. And when you go for the 110 degrees centigrade, that viscous liquid may become the pure liquid. So actually we cannot say At what temperature the plastic material started melting. Melting point means conversion of a solid directly to the liquid. But in this process we obtained the liquid here, viscous liquid, here we got the soft material. So solid is here, solid initially converted to the soft material at 90 degrees centigrade, then to the viscous liquid, then to the pure liquid. So there is a range of temperatures are there. So started at one particular temperature and that melting process ended at another particular temperature. Hence we say amorphous solids are having the range of melting point values. These are isotropic in nature. Isotropic means you can take any direction. Along all the directions, these amorphous solids are having the different type of the arrangement of the particles. Hence their properties will be same along all the directions, means they don't give the proper values along all the directions. Hence this type of the amorphous solids are said to be isotropic in nature, and when you apply the pressure there may be dislocation of the particles, because the particles are not arranged properly. There will be dislocation of the particles, hence these solids are said to be little bit soft in nature compared with crystalline solids. And moreover, amorphous solids do not maintain the long range order. See here A, B order is only till here. Next again A are there. Afterwards again A, B is there. Again A is there. So the amorphous solids do not maintain the long range order. They maintain only the short range order. Hence amorphous solids are called as the pseudo-solids. Let us see the general characteristics of the amorphous solids. These are the general characteristics of the amorphous solids. Directly you can take the screenshot as a notes. Classification of crystalline solids. Crystalline solids are classified into 4 types based on the nature of intermolecular forces in them. They are molecular solids, metallic solids, covalent or network solids, or ionic solids. Now let us see one by one. First one is molecular solids. So molecular solids, in molecular solids the constituent particles are molecules. Only molecules make these solids. These molecular solids are again divided into 3 types: polar molecular solids, non-polar molecular solids, hydrogen bonded molecular solids. Now let us see about the polar molecular solids. So in polar molecular solids, the attraction forces that exist among the polar molecular solids is covalent bond. But here we said polar. So the molecules are having the polar covalent bond. If you take the HCl molecule, let us take HCl here. Due to the electronegativity difference between the hydrogen and the chlorine, chlorine gets the partial negative charge, hydrogen gets the partial positive charge. Here also same, partial positive charge and partial negative charge. Now these are the two dipoles, negative dipole and positive dipole of different molecules. So when these molecules are placed in this single container, so there may be some attraction forces may be developed between these opposite charges which hold these molecules together as a molecule. So these attraction forces we call as a dipole-dipole forces, because the attraction forces developed between the two opposite charged dipoles of two different molecules. And dipole-dipole interactions are very weak, and these molecules are soft in nature. As there is no ions formed in this molecule, these molecules are non-conductors of electricity. Generally at room temperature, these molecules, polar molecular solids, exist as the gases. Now let us see about the non-polar molecular solids. So in non-polar molecular solids are formed by either atoms or molecules. Either atoms or molecules. Atoms means noble gases. Molecules means non-polar molecules. Polar molecules, non-polar molecules. Here polar molecules means just now we have taken HCl is a polar molecule. It's a molecule where poles are formed. Partial positive charge, partial negative charge. Non-polar molecules means, for example, if you take the hydrogen molecule, since electronegativity of both the hydrogen atoms is same, so that zero charge will be formed on the both atoms. If you take the chlorine also, zero charge will be there. If you take the iodine atom, zero charge will be there. Such type of the molecules are called the non-polar molecules. Both the polar molecules and non-polar molecules are having the covalent bond only. But in the case of the polar molecules, due to the charge separation, polar bond will be formed. So that is the reason why dipole-dipole interactions are observed in the polar molecular solids. But in this case, no such type of the separation of the charges are there. Hence, we cannot expect dipole-dipole forces. Wherever dipole-dipole forces are not there, or wherever no charge separation is there, in such type of the molecules, we can observe only one type of the forces. They are called the London forces or dispersion forces. These are very weak force of attraction. For example, if we take the two hydrogen molecules, even though no charge separation is there, some attraction force exists among these molecules. Weak attraction force will be there. That weak attraction force is called as the London forces or dispersion forces. Since no ions are present, these are also non-conductors of electricity. Due to the presence of the weak force of attraction, these are soft in nature. They are also usually present in the gaseous state at room temperature. Now let us see hydrogen bonded molecular solids. So in the case of the hydrogen bonded molecular solids, as the name suggests, these molecules are having the hydrogen bond. So hydrogen bond is formed only between the hydrogen along with the fluorine, oxygen or nitrogen. So these atoms must be present in the given molecule to observe the hydrogen bonded molecular solids. For example, if you take the water molecule, in water there is a charge separation due to the electronegative difference between the oxygen and the hydrogen. Oxygen in all the water molecules gets the partial negative charge, whereas the hydrogen atoms gets the partial positive charges. So here partial positive charge, partial negative charge, if these molecules are placed in the same container, then we can expect some type of the attraction forces. That attraction forces in this case is called as the hydrogen bond. Earlier case we called them as the dipole-dipole interactions. Here we are calling the same dipole-dipole interactions are as hydrogen bond. So dipole-dipole interaction, if it is formed between partial positive charge, partial negative charge of any molecules is called as dipole-dipole interactions. But if the same dipole-dipole interaction is observed between the hydrogen along with the any of these atoms, either fluorine or oxygen or nitrogen, such type of the dipole-dipole interactions are called as the hydrogen bond. This hydrogen bond is little bit stronger than the normal dipole-dipole bonds, because all these fluorine, oxygen, nitrogen are the strong electronegative atoms. Stronger the electronegativity, stronger will be the dipole-dipole interaction formed. Hence, hydrogen bond is a type of dipole-dipole interaction, but it is a stronger dipole-dipole interaction than the normal dipole-dipole interaction. And since there is no ions are present, so these are also non-conductors of electricity. But due to this presence of the stronger hydrogen bond, they possess a little bit higher boiling point values and melting point values also, and they always exist in the liquid state. So now let us discuss the metallic solids. These are the notes of the metallic solids. So before discussing these points, let me explain what are the type of the bonds present in the metallic solids. If you take any metal, imagine this is a metal. Generally metal is having the metal atoms. Imagine these are all metal atoms are present. We know that metals are the elements with less electronegativity and more electropositivity. Means these metal atoms can easily lose the electron. Imagine each metal atom is losing the one electron. All these metal atoms are losing one electron. Like this, these are the electrons. Blue colored particles are electrons, red colored particles are the metal ions. So now after losing the electrons, these are called as the positive charges. So a metal ion can lose one or more than one electron. If this is a alkali metal, alkali metals and alkaline earth metals, they lose only single one electron or two electrons. We can see here alkali metals, alkaline earth metals and D block metals. Alkali metals, they lose only one electron. Alkaline earth metals, they lose the two electrons. D block metals, they may lose more than two electrons also. So you imagine these are the only alkali metals, they lose the only one electron. So this one electron will hold these positive charged cations. These positive charged cations are called as the kernels. The metal atoms in positive charge in the metals are called as the kernels. So these kernels are looking like that they are immersed in the sea of electrons. And these electrons are holding these positive ions together, and there is a strong attraction forces present in the metals. Here you can see one particular positive charge is surrounded by the many negative ions, and similarly each negative charge is surrounded by the many positive charges. So strong attraction force will be developed among these opposite charges, hence metals are strong solids. And these electrons are called as the free electrons. These electrons can move from one particular place to the another particular place. So that is the reason why these are the good conductors of both electricity as well as the heat. But when you compare the alkali metals and alkaline earth metals, in the case of the alkaline earth metals, more electrons will be there because they are capable of giving the more than one electron, that means 2 electrons. So when the number of electrons increases, then the attraction forces between the cations and electrons also increase. So the strength of the metal also increases. Hence alkaline metals are stronger than the alkali metals. And in the case of the d block metals, they are capable of releasing the more than 2 electrons. So this is completely filled with the only electrons, and these electrons are called as the electron sea because it looks like a sea. And now the kernels or the metal ions are looking like that they are immersed in the sea of the electrons, and these electrons will hold the metal cations very strongly with them. Hence these metal ions cannot move a particular from their position, and only electrons move from their position, and electrons are the responsible particles for the carrying of the electricity or heat in the metals. When the number of electrons increase, the attraction force of the cation, the attraction force between the cation and the negative charge also increases. So the strength, when the attraction force increases, we can say that the strength of the metal also increases. So the attraction force between the metal cation and free electrons is called as metallic bond. There is a large difference between the metallic bond and ionic bond. For example, if you take NaCl, in NaCl, Na plus ion and Cl minus ion is attracted to each other, and these are the ions. So when they are attracted to each other, when the attraction force is present between the two ions, that is called as ionic bond. But in this case, metal ions are attracted to the electrons, not to the any other negative charged ion. So such type of the bond is called as the metallic bond. More the number of free electrons, stronger will be the metallic bond formed, and the stronger will be the metal. But all metals are capable of conducting the electricity and capable of supplying the heat energy. Since alkali metals are able to produce only one electron, alkali metals are soft in nature. Alkaline metals are little bit hard compared to the alkali metals, and D block metals are completely hard compared to the both alkali and alkaline earth metals. So the strength of the metallic bond or the nature of the metal depends on the number of electrons the metal provides to the electron sea. Now you can see these are the general characteristics of the metallic solids. They possess high electrical and thermal conductivity. When electric field is applied, the mobile electrons flow through the network of positive ions, just now we discussed. Similarly, when heat is supplied to one portion of the metal, the thermal energy is uniformly spread throughout by free electrons. They possess luster and color in certain cases. This is also due to the presence of free electrons in them. So when visible light falls on the metal, the free electrons oscillate about their main position and reflect light in all the directions, and thus are lustrous. They are highly malleable and ductile. They have high melting point values. Here we need to discuss about this particular point, lustrous, glittering nature. So when metal is cut a particular position, then it will provide the new surface area. So this new surface area will be having the electrons, that is sea of electrons, so that whenever light falls on the sea of electrons, these electrons may go for the excitation and de-excitation process, just like in hydrogen spectrum we studied. So these electrons, when they absorb the light energy, they go to the higher energy state and they may come back to the lower energy state. So due to the oscillation of these electrons to the higher to lower energy states, When they go to the higher energy state, they absorb the energy, and when they come back to the lower energy state, they release the energy. So due to these oscillations, it looks like they are glittering or they are called as lustrous. Now let us see covalent or network solids. Covalent or network solids means here only covalent bond will be there and they form the network like structure. So that is the reason why these are called the covalent or network solids. These covalent or network solids are very hard and brittle since the covalent bonds are strong and directional in nature compared to the remaining bonds. They have extremely high melting point values and may even decompose before melting. They are insulators and do not conduct electricity. Here two best examples are given, both diamond and graphite. You know that in diamond, it is having tetrahedral shape like this. So each carbon is connected to the 4 other carbon atoms through tetrahedral shape. So here also you can see this is a tetrahedral shape, and here also you can see tetrahedral shape, and here also you can see tetrahedral shape. Everywhere you get the same tetrahedral shape, but finally it looks like a giant molecular structure. So due to the giant molecular structure, these are very hard in nature, and due to the absence of the free electrons, diamond is the non-conductors of electricity. So most of the covalent or network solids are the insulators except graphite. Graphite is a soft material and a good conductor of electricity due to its layer structure and sp2 hybridization of the carbon and the presence of the free pi electrons. So this information is available in the 14th group elements, you can see there. The last one is ionic solids. So in the case of the ionic solids, we know that ionic solids are nothing but the bond that is formed between the two ions. The attraction force that present between the two opposite charged ions is called as the ionic bond. This ionic bond do not have the direction, because you can expect the bond between the Na plus and Cl minus in this direction, or else from this direction also, or else from this direction also. Any direction, 360 degrees you can get the ionic bond. So that is the reason why ionic bond is not directional in nature. Moreover, there is no participation of the orbitals in the ionic bond, hence ionic bond do not have the direction. Since it is not having the direction, it can form the ionic bond in any direction, hence it is a particular cation is attracted to the anion in all the directions, hence they are very strong, brittle in nature and having the high melting point values and boiling point values. These molecules, ions, these ionic compounds are completely non-conductors of electricity in solid state, because a particular cation is surrounded by the many anions, so that particular ion cannot move from its position. But whenever these ionic solids are dissolved in the polar solvents, they immediately ionize into their respective ions, and these are the free ions in the liquid state, and they can easily conduct the electricity. Hence, ionic solids are good conductors of electricity in the liquid state or molten state, but are the bad conductors of electricity in the solid state. This is about the introduction of the solid state. Hope you understand it.